One of Buick's most convenient features is the cruise control system. The vehicle can maintain almost any speed set by the driver. Two systems are currently in use: the vacuum servo system, like the one on this Park Avenue, and the Roadmaster's Electro motor system. In either system, a cruise control microprocessor is used to sense vehicle speed and command a vacuum servo assembly, or a stepper motor, to maintain the vehicle speed by opening or closing the throttle. In reality, Buick vacuum servo cruise control system components have not changed all that much since 1990. Since 1990, the controller module has been placed in several locations, depending on the type of system used and the vehicle. The know-how manual charts identify the specifics for you. Many systems have new disabling features. Let me show you the different cruise control system types. We'll start with the cruise control module system. This system contains all cruise control circuitry in a separate module. This system is used in Skylark with the 2.3-liter quad OHC or 3300 V6, Century with the 3300 V6, Regal with the 3.1-liter V6, and with the 3800 engine, and pre-92 LeSabre. Next, the 1990 Riviera and Riata cruise control functions are housed in the BCM. The BCM uses its own set of diagnostic trouble codes, or DTCs. The BCM disables cruise control for many reasons. For example, the system won't engage if the Set Coast push button is pressed within 2 seconds of switching the system on. Check out the reference manual for all other disabling features. Both the Century and Skylark with the 2.5-liter engine use the ECM to operate the cruise control system. The ECM uses several methods to disable the cruise control system. For example, the ECM prevents cruise control engagement if the driver tries to engage cruise control before the engine has been running 10 seconds. Since 1991, cruise functions for Riata, Riviera, Park Avenue, 93 Regal with the 3800 engine, and the 92 and 93 LeSabre are controlled by the PCM. This Park Avenue disables cruise control if the PCM sees a throttle position sensor problem. Before 1991, if the TPS failed, a TPS default mode was used. The default mode tended to cause a surging cruise control condition. Another important system feature is that if the PCM sees an electrical failure in the 4T60E transaxle, cruise control is disengaged. Here's another feature. When cruise control is engaged, the PCM changes the transaxle shift schedule by delaying downshifts that would normally occur with a change in throttle position. This permits a smooth flow of power without an unexpected downshift. As you know, PCM systems can be diagnosed with the Tech 1. The PCM assigns cruise control DTCs for failed or problem circuits. The Tech 1 can monitor brake switch, vacuum solenoids, and servo position sensor data. The Tech 1 can also test the on-off, set coast, and resume accelerate switches. Occasionally, customers complain of an intermittent cruise release condition on Park Avenue and LeSabre. One possible cause is a cruise vacuum release switch installed upside down. When the hush panel is in place, it presses against the switch, binding it so the vacuum valve leaks. Then when the hush panel is removed, pressure against the switch is removed, making this problem difficult to diagnose. Now, let's cover 91 to 93 electromotor cruise control. Keep in mind that variations of this system are scheduled to appear on 1994 Century and Regals. I'll start by pointing out components, explain their operation, then touch on some highlights for testing the system. Components of the system include a cruise control mode switch, which I'm sure you know includes an on-off slide switch, a set coast push-button switch, and a resume accelerate slide switch. The TCC cruise release and brake light cruise release switches mounted near the brake pedal lever are used to disengage the system when the brake pedal is depressed. The vehicle speed sensor and the vehicle speed sensor module supply vehicle speed information to the cruise control module. The cruise control module is normally a unit replacement. However, a quick look inside will help you understand the characteristics of the electromotor system. The module houses the cruise control electronics, the stepper motor, a gear set and clutch, and the connecting strap. The cruise control stepper motor utilizes 3 switching circuits to activate 3 separate sets of field coil windings. Energizing a coil pulls the poles of the armature into alignment. The armature rotates 1/3 of a turn to align as each coil is energized. Because the coil sets are individually switched, the motor can be rotated as little as 1/3 turn, held motionless, or reversed. When the stepper motor rotates, the connecting strap and cruise control throttle cable move the throttle to maintain, increase, or decrease vehicle speed. The system can open the throttle up to 80% of wide open throttle. The system is disengaged when the brake pedal cruise release switches are actuated, or when the system is switched off. Here's a customer complaint you may have come across. Cruise control makes a clattering noise when the system is switched off at the control lever. Well, here's the deal. When the customer uses the brake to release cruise, the stepper motor unwinds to gradually release the throttle. But when the customer uses the on-off switch to release cruise, the gear clutch in the module disengages immediately. If the throttle is open wide enough at the time, you get a throttle slapback like this, which can be heard by some customers. Assure your customers that this is a normal condition. 2 versions of the stepper motor system are on the road. 1991 and 92 Roadmasters up to VIN sequence number 21429 use the first system. Roadmasters after that breakpoint use the second system. In first design systems, the brake switches are wired in series and, when actuated, open to remove power from the module to disable cruise control. Second design systems can be quickly identified by this yellow wire at terminal G. Second design systems provide a redundant method of detecting brake pedal movement. One brake switch removes power from the module, while a second brake switch completes a brake input circuit. The module's current limiting resistor maintains about 0 volts on the circuit, not enough to illuminate the chimsel. When the brake pedal is pressed, the brake light cruise release switch closes, sending full battery power to the module and to the chimsel. Anytime the module senses power above 7 volts, it disengages cruise control. Also, if the module senses that current is not being pulled low due to an open or intermittent, the cruise control module won't engage. Even a trip from a local lumber yard won't let cruise control engage because this circuit is not completed. And that's how the system works. Anytime the system doesn't work, that's your cue for a road test to begin the diagnosis. Remember, the Roadmaster Service Manual is your official source for diagnostic procedures. But let me highlight some tests you can perform rather quickly. If you can verify the complaint, there are several tests to perform. We'll get to those in a minute. But first, suppose your road test didn't verify the complaint. That tells you that you've got an intermittent on your hands. Finding it Well, that's the real trick. So let's get started. Intermittent trouble can be caused by a loose or dirty ground at the rear of the right cylinder head. Perform a quick voltage drop test. Connect the meter to the terminal and the negative battery terminal for a true reading. Switch on the ignition and cruise control. You should see 1/10 of a volt or less. Anything higher means that excess power is needed to penetrate a poor ground. Remove the ground, degrease and wire brush the ground site and all terminals. Reinstall the terminals and tighten the nut. Another potential for intermittent operation is a misadjusted brake switch. I'm referring to a switch that's teetering on the verge of misadjustment. It's okay 1 minute and not the next. If you have such a condition, the module thinks the driver is constantly tapping the brakes, so it won't let cruise control engage. To adjust the switches, press the brake pedal down, push both switches fully into their retainers, then pull the pedal back to its retracted position to adjust both switches. As you know, a loose or damaged terminal can cause intermittents. Slightly tug on each wire to be sure its terminal is seated. If all wires are tight, remove the connector. Carefully check all harness terminals for a snug fit with the test terminal from the test adapter kit. This is vitally important. All cruise control system connectors depend on clean, tight, and dry connections. Therefore, each terminal in the system should be inspected. Replace any bad terminals. Also be sure to inspect the connector for internal cavity damage. Another test for intermittents is to check the power and ground wiring to the cruise control module. Remove the cruise control module connector. Attach a voltmeter between terminals F and E. You should see battery voltage only when the ignition is on. Wiggle the harness, looking for any change in the meter reading. Now, let's do another test. The mode control switch wiring routes through the steering column. Movement of the tilt wheel, turn signals, and high beam switch has the potential to pinch or cut wires, causing circuit intermittents. To check the wiring, move the meter lead from F to A. With the ignition off, then on, you should only see 0 volts. Now, slide the cruise on-off switch to on. You should see battery voltage. With the switch still on, operate the tilt wheel, actuate both turn signals, and switch the high beam headlights on and off. If the meter fluctuates, and intermittent in the steering column may be present, check for a stuck switch by moving the cruise control switch off. The meter should show 0 volts. Move the lead from A to B. With the ignition off, then on, you should see 0 volts. Switch the cruise on-off switch to on. Now, push the set coast switch. You should now see battery voltage. Perform the tilt, turn signal, and high beam test again, then release the set coast switch. Press and hold the resume accel switch. You shouldn't see any voltage. If you do, you've got a short between the resume accel and set coast circuits to repair. In normal operation, pressing set coast and resume accel at the same time disables cruise control. You'll see the same results with a short between these circuits. Now, let's check the brake light cruise release switch circuit for intermittents. This is done by jump ring terminals G and F. Power should only be present on the CHMSL circuit when the ignition is switched on. Jiggle connector C405 in the left rear quarter panel area. If the CHMSL blinks or flickers, this indicates an intermittent. Then, grasp the back glass lift handle and jiggle the rear glass. Watch the illuminated CHMSL. If the lamp blinks or flickers, that's an intermittent. Take a close look at the CHMSL contact pins on the rear door for corrosion. Any interruption prevents cruise control operation. Then, inspect the back glass contact plate, looking for leaks. Remove the corrosion, repair the leak, and retest the circuit. Buick Service Bulletin 92-9-16 addresses a problem where cruise control doesn't work due to corrosion at the contact pins and plate. A resistor must be soldered to the circuit to provide the ground the module is looking for if corrosion becomes excessive, or if both CHMSL bulbs burn out. To check out the other brake release switch circuit, connect the voltmeter across terminals D and E. This test is valid for first and second design systems. With the ignition off, the meter should display 0 volts. However, when the ignition is on, the meter displays battery voltage. Now press the brake pedal. The meter should go to 0 volts. Then show battery voltage when the brake pedal is released. Okay, that should cover intermittent problems. Let's back things up a little bit. Now suppose that during the road test you performed earlier, the car actually demonstrated the customer's complaint. For example, check out the cruise control throttle cable. A misadjusted cable causes a lazy response, while a broken cable renders the system inoperative. To see if the cable is broken or just needs an adjustment, remove the retainer clip and pull the cable end off of the stud. If you feel the cable extend in the slightest, adjust it. If you pull it right out of the housing, replace the broken cable. Here's how to adjust the cable. Lift the cable lock and pull the cable end until the throttle just begins to open. Then, slowly close the throttle. As the throttle just closes, lock the adjustment mechanism. After the cable adjustment, perform the initial system check to verify circuit and switch functions. To perform the system check, set the park brake and start the engine. Move the cruise on-off switch to off, then back to on. After at least 3 seconds, press and hold the brake pedal. Push and hold the Set Coast button, and then the Resume Accel switch. After 10 seconds, release the brake pedal. Engine RPM should momentarily increase. Then return to idle. If the system passes this test, you should also look at the vehicle speed signal, which we'll do in a few minutes. For now, if the system fails this test, perform all pinout tests at the cruise control module connector using the J39200 multimeter, a jumper wire, and terminal adapter test kit J35616. Of course, start by checking ground G104. Test for power to the module, adjust the brake switches, and perform the intermittent test as previously shown. Now, check the speed signal at the VSS module. Remember, if the Tech 1 reads vehicle speed and the speedometer looks okay, that's no guarantee that the cruise module senses vehicle speed. To check the cruise module, isolate it by disconnecting the audio alarm module connector C222 and the power steering control module, if equipped. Then disconnect VSS module connector C1. Back probe the connector from terminal D to ground. Switch the ignition on and then cruise control. If you don't see 5 volts, there's a problem with circuit 389 or the module. Check the module at terminal K. If you don't get 5 volts, replace the module. If it's okay, repair circuit 389. If you got 5 volts originally, reconnect the VSS module, then connect the meter between terminal D and ground. Raise the vehicle on a hoist and attach an exhaust hose if required. Connect to Tech 1. This provides you with a digital speedometer. Start the engine. Place the gear selector in drive and allow the wheels to rotate. The VSS frequency is proportional to vehicle speed by a factor of 1.1 to 1. If you don't get anything, check the sensor itself. Look for about 0.2 volts AC at 2 miles per hour and up to 100 volts AC. If it doesn't produce similar readings, replace the sensor. Something else you should be aware of is a surging cruise control condition. This is due to the stepper motor sensitivity to speed sensor variations. Remove the sensor and inspect the gear for out of round or for worn teeth. Inspect the sensor drive shaft and sensor slot for looseness. If there is movement whatsoever between these components, or if the gear is worn, replace them. If cruise control problems seem puzzling, use system knowledge, persistent diagnosis, and proven repair techniques to fit the pieces together, with the goal of maintaining Buick as the new symbol for quality in America.